So in the previous class which happened yesterday, assignment 4 was being discussed and he completed till question 5. So today I will start with question 6. So please go through the question. I hope everyone who is attending now has already attended the classes and are familiar with these questions. Refer the following circuit and answer 6-7 questions. It is that of the assignment. Prepare the G matrix and I matrix and solve for the voltages using super node. Please go through the question yourself. We'll start solving it in 2 minutes. I hope you all went through the question. So let us solve this. You all are familiar with the voltage drop which occurs across a impedance Z. So if current I is a current flowing through an impedance, there will be a voltage drop V, where V is given by I times Z, or I is equal to V by Z. This can be written as Z inverse into V where Z inverse is the admittance of the system. Now when you take a simple resistor and you pass a current I, there is a voltage drop of V, where V is given as I into R, or I is equal to R inverse into V, where this R inverse is called the conductance. So when you have an inductance also involved, then your impedance will come into picture. Impedance is nothing but, or admittance is nothing but, conductance plus J into susceptance. We are not dealing with AC circuits as of now. So we are only dealing with a resistor, and the inverse of a resistor is called conductance. So in matrix form, if you have a V matrix, if you have a conductance matrix, and if you have a current matrix, so V, G and I, then you can write V is equal to G inverse, I is equal to G times V. Where G is called the conductance matrix. Now, if you have a system with n nodes, n independent nodes, then the size of your conductance matrix, size of G, will be n minus 1 by n minus 1. That means if you have 4 nodes, then the size of your conductance matrix will be 3 by 3. And I hope you all are familiar with matrix multiplication. So if you have an m by n matrix, it can only be multiplied with another matrix whose number of rows is same as the number of columns of the previous matrix, because this corresponds to number of rows and the second number corresponds to number of columns. Now this matrix can only be multiplied by another matrix whose number of rows is same as the number of columns of the previous matrix, and its size can be anything, say n cross h. When you multiply this matrix with this matrix, you get a matrix whose size is m by h. I hope this is clear. Now, let us go to our question. So, given this circuit, you have to prepare the conductance matrix and current matrix and solve for the voltages. Means that your I is equal to G times V. You have to find what is your G and what is your I, and in turn you have to find what is your V. Because this will be known and this matrix will also be known, whereas V is the unknown matrix which you have to find out. So you are applying Kirchhoff's current law in these nodes, and those Kirchhoff's current law equations, you are writing it in the form of matrix and you are solving it. So there are several ways to solve this circuit. You can directly write node equations and use the equations, number of equations and unknowns and solve, or you can use the matrix method. But in the given question, it is inherently asked to prepare the conductance matrix. So let us move that way. So in the given circuit, you have 1, 2, 3. You see, this is another node. No, it is connected to same 3 because there is no elements in between. So this is also 3, this is also 3. Also you have 4. Now there is a fifth node. These all are single node because there are no elements between them. So this node is the reference node. As I have explained before, any node you can take as reference, but in the given problem, it is inherently given the reference node. So reference node means its voltages you can take as 0 volts. So now you have to solve the equations using nodal analysis. Now there are 4 nodes. So number of nodes n is equal to 4. So the size of your conductance matrix will be 3 by 3. Conductance matrices will always be a square matrix. Then only the inverse exists. So the matrix should be square as well as its determinant should be 0. Then only the inverse will exist. So now let us write the equations, nodal equations for the given circuit. So you have node 1. This is my node 1. In node 1, 1 kilo ohm is connected. Another 1 kilo ohm is connected. A 7 milliampere current source is connected. And another current source of 3 milliampere is connected. Now when you write KCL or when you apply nodal analysis on a particular node, you will write the KCL equations, which is incoming currents is equal to outgoing currents. Now, whether they are really incoming or really outgoing, we don't know. We just assume a variable, we assume a particular direction and we write the KCL equation. And also you know that current is given by voltage by resistance. So these two you should know, then only you can write the nodal analysis node equations. So already 7 milliampere is given and 3 milliampere is given. So there is no need to assume it. Now, across this 1 kilo ohm, this 1 kilo ohm, here there is another node, node 2. And I can name voltage variables. This is V1, this is V2, this is V3 and this is V4. So in this case, this is V1 and this is V2. Now the current through a resistor whose potentials at both ends, let it be V1 and V2 and the resistance values are, if you assume the current direction from V1 to V2, say I1, then I1 is given by V1 minus V2 by R. Now say I assume current to be like this, say I2, then I2 will be V2 minus V1 by R, because current always flows from higher potential to lower potential. So this is anyway, you know, I1 is minus I2. So the point I want to make is, I am assuming that the current is like this. It is our choice. So this current is given by V1 minus V2 by 1, which is 1 kilo ohm. Okay, so continuing with our assumption, similarly, this 1 kilo ohm, the other end is grounded, which means it is 0 volts. So the current through this 1 kilo ohm, if I am assuming the direction is like this, then it is V1 minus 0 by 1. So now you got the currents through all the branches connected to node 1. Now we can write the KCL equation. So the incoming currents, which are the incoming currents? Currents which are coming to the node. That is this 3, only that 3 is incoming. So you can write 3 is the incoming current. Now what is the outgoing current? 3 milliampere. Always make sure you are following the units. Now outgoing currents are V1 by 1, V1 minus V2 by 1 and 7. So I can write the outgoing currents as V1 by 1 plus V1 minus V2 by 1 plus 7. So our KCL equation is, according to Kirchhoff, all the currents which enter the node should leave the node. That means V1 by 1 plus V1 minus V2 by 1 plus 7 is equal to 3. Now the currents are all in milliampere and resistances are all in kilo ohm. So when you multiply milliampere times kilo ohm, milli is 10 raised to minus 3, kilo is 10 raised to 3. So this will comes 1 and ampere times ohm is volts. So when you multiply the currents in this branch and resistor, you will get voltage in volts. That is why I am not inherently writing 10 raised to minus 3 or 10 raised to 3. Hope you all understood my point. So this is the first equation of node 1 or nodal equation in node 1. Now I am going to my second node. So when you take the second node, you have 1 kilo ohm and 2 milliampere current source. So if I redraw my node 2, there is a 1 kilo ohm, there is another 1 kilo ohm, sorry, not here, there is another 1 kilo ohm and there is a 2 milliampere here. Now the potentials at the other end of this resistance, this is V1, this is V2, this is V3 and this is your ground, 0 volts. Now you assume the current directions. I am assuming all are outgoing. Sorry, this I cannot assume because this is already 2 milliampere incoming. Now this current is also outgoing. So now my outgoing currents are V2 minus V1 by 1. You can stop me whenever you feel doubts or if I am doing wrong. V2 minus V1 by 1 plus V2 minus V3 by 1. These are the outgoing currents. This is equal to incoming current. So this is our equation number 2 or this is the nodal equation at node 2. Now I go to third node. So in third node you see This 3 milliampere goes out. It is either connected to 1 kilo ohm, another 1 kilo ohm, another 3 milliampere and a voltage source. Now, the current through this voltage source you don't know. So let me redraw the circuit. So this is the interesting part. This is called the supernode. Now what is a supernode? Supernode is a node which has those are two nodes in between a voltage source is connected. Now, if I redraw my third node, there is a 1 kilo ohm connected to node 3. There is a 3 milliampere current. There is another 1 kilo ohm. There is a voltage source of 2 volts and there is my node V4. Now these two are node 3. Now another current source of 3 milliampere goes out. Now this is your node 2, so this is V2. This is V3. Now you see this V4 is further connected to a 1 kilo ohm resistor and a 5 milliampere current source. Now these all are connected to ground. So if you see node 3, I am assuming the directions of current which are not given as outgoing. So this is outgoing, and this is also outgoing. So now the currents which reaches third node or node 3 is the incoming currents are this 3 milliampere. So 3 milliampere is a incoming current. Now which are the outgoing currents? Outgoing currents is this another 3 milliampere plus this one, this guy. He is V3 minus V2 by 1. Then this guy is outgoing. He is V3 by 1. Now 1, 2, 3, 4. 1, 2, 3, 4. You have written 4 currents. Now what is the fifth current? Fifth current is this guy. Let me name it as I5. Now this I5 is also outgoing. Now you have to express this I5 in terms of V3. How can we do that? So you see this I5 is going here and it is now getting splitted to I6 and this is 5 milliampere incoming. So this I5 is nothing but I5 is I6 minus 5. You just apply KCL at this node V4. So when you apply, I5 and 5 are incoming and I6 is leaving. So now what is this I6? Your I6 is nothing but this current. This current is connected between V4 and ground. So I6 is V4 by 1 minus 5. So your I5 is nothing but V4 minus 5. Now what is this V4? What is this V4? V4 is what? You know this 2 volt. Your 2 volt is connected between V3 and V4. That means the difference is 2, which means V3 minus V4 is equal to 2. If this polarity was reversed, if your voltage source was like this, V3 and V4, then the higher potential minus lower potential, V4 minus V3 is 2. Okay, so in our case, V3 minus V4 is 2. So I can replace this V4. So V4 is V3 minus 2. So I can replace here. So your I5 is nothing but V3 minus 2 minus 5 or V3 minus 7. So you got your this value. So I can replace it there and fill the KCL. So 3 milliampere is equal to 3 plus V3 minus V2 by 1 plus V3 by 1 plus V3 minus 7. Did everyone get the same answer? Okay. Now if you solve this, 3 and 3 will cancel out. So this is V3 minus V2 by 1 plus V3 by 1 plus V3 minus 7 or is equal to 7. Now this is your nodal equation at node 3. So let me bring my two nodal equations. First equation, second equation, and third equation. So these three are my nodal equations. Now how to construct the conductance matrix from this? Now let us rewrite this. I am rewriting my first equation as V1. What are the coefficients of V1? V1 is 1 plus 1, which is 2. Now of V2 plus V2, coefficient of V2 is minus 1, is equal to 3 minus 7, which is minus 4. Now the second equation, similarly, V1's coefficient is minus 1 plus V2 times V2 is 1 plus 1, 2. Now V3 is also coming. So in the first case, there is no V3, so here it is V3 into 0. Now in the second equation, V3's coefficient is minus 1 is equal to 2. Now the third equation becomes V1 into 0. V1 is not there. Now V2 into minus 1 plus V3 into 1 plus 1 plus 1, 3 is equal to 7. Now you have, this is of the form V into G is equal to I. Now what is V? Sorry, you cannot write V into G because V is a 3 by 1 matrix. So you have, as I mentioned before, you can multiply only if their number of rows and columns are together. So I can rewrite this as 2 minus 1, 0. So I wrote 2 here, minus 1, 0. Then minus 1, 2, minus 1, 0, minus 1, 3. This time, so this is a 3 by 3 matrix. I can multiply 3 by 3 matrix with a 3 by 1 matrix because 3 and 3 are same. This is V1, V2, V3. Note the point, you can never write V into G. Always write G into V because V into G is a 3 by 1 matrix times 3 by 3 matrix. This multiplication cannot be done. So this is equal to your I matrix. I is minus 4, 2, 7. So you got your conductance and current matrices. So this is the first part of your question. Find the conductance and current matrix. So this is of the form G V is equal to I. So your conductance matrix is 2 minus 1 0, minus 1 2 minus 1 0, minus 1 and 3. And your current is minus 4 2 7. So this is the first answer of your question. I hope everybody got this answer. Now you have to find V1, V2 and V3, V4 in the above circuit. So you have to solve this equation. So you can go by different methods. Some people will be, so if you write this way, then your V is G inverse times I. Note the point, G inverse is also another 3 by 3 matrix. Inverse of a matrix has the same number of rows and columns and your current is a 3 by 1 matrix. That's why you are writing G inverse into I and not I into G inverse. This is wrong because I is 3 by 1 matrix and G is a 3 by 3 matrix. This multiplication can never happen. Always remember this, this can never happen. Always write V is equal to G inverse. Sorry, V is equal to G inverse times I. Now, some of you are familiar with inverse. Inverse of a matrix is adjoint of a matrix by determinant of that matrix. You can either go this way, if you are familiar with finding adjoint and determinant, or you can use the Cramer's rule, which is the simple rule. Now, according to Cramer's rule, if you have a matrix, say A11, A12, A13, B11, B12, B13, C11, C12, C13 with X, Y, Z is equal to A, B, C. If this is of the form, then X is given by, so X corresponds to, your X corresponds to this row. So X is given by, sorry, so your X is given by this column. So when you are finding X, you should replace this column with ABC. So X is given by determinant ABC, A12, B12, C12, A13, B13, C13 divided by the determinants of A11, A12, A13, B11, B12, B13, C11, C12, C13. So I am naming this whole determinant as determinant of D. So this matrix is called D. So this is Cramer's rule. So if you want to find Y, we should replace this column with the non-values ABC. So Y is equal to matrix Y, the value Y, not matrix, Y is equal to A11, A, A13, B11, B, B13, C11, C, C13 divided by the determinant of this matrix D. So you just replace, if you want to find Z, then replace this column with ABC. So if you follow this way, you have your conductance matrices and current matrix. So you already know this and this. So your V1 is given by determinant. So when you write V1, you replace this column with -4, 2, 4. So -4, 2, 7, -1, 2, -1, 0, -1, 3 divided by the whole determinant of your G, which is determinant 2, -1, 0, -1, 2, -1, 0, -1, 3. I hope you all know how to find the determinant of a matrix. So this determinant, I will calculate one determinant for just illustrating. So when you find determinant, it is the first element 2 multiplied by 2 into 3 minus -1 into -1. Now when you write this element, every time you multiply determinant with -1 raised to I plus j, where I is the row and j is the column. So this is your 1, 1. The position of 2 is in 1, 1, whereas the position of -1 is in 1, 2. So your I is 1 and j is 1 in the first case, in the case of 2. So in the case of 2, this value is 1 plus 1. Now in the second case, when you take -1, so -1 into -1 times 3, -1 times 3 minus of -1 times 0, which is 0. Now you have to multiply this with -1 raised to I plus j, where I plus j is 1 plus 2. Next term is anyway 0. So this becomes 1 plus 1 is 2. So -1 square is 1. So this is 2 into 2 3s are 6 minus 1 into 1 minus plus minus 1 times minus 3. Now minus 1 raised to 3 is again minus 1. So this is minus 1. So this determinant value comes out to be 7. Similarly, if you find this determinant, so V1 is this determinant. So the first determinant's value will come out to be minus 7. So this is minus 7 by 7 and your V1 will come out to be minus 1. If you write V2, V2 is nothing but you replace the second column with minus 4, 2, 7. So it becomes 2, minus 1, 0, minus 4, 2, 7, 0, minus 1, 3. This divided by determinant of your whole matrix is you already obtained as 7. So divided by 7. Similarly, your V3 will be, you replace the third column, 2, minus 1, 0, minus 1, 2, minus 1. You replace this with minus 4, 2, 7. So this determinant by 7 will be your V3. Now your V2 comes out to be 2 and your V3 comes out to be 3. So your answer V1 is minus 1 volts, V2 is 2 volts and V3 is 3 volts. Now you are also asked V4, but you already know that V3 minus V4 is 2. So your V4 is V3 minus 2, which is 3 minus 2 or 1 volts. So the answer is minus 1, 2, 3, 1, which is first one. I hope everybody understood. If there is any doubt, please ask. Now let us move on to the next question, which is a continuation of the same question. So you are asked to find the power delivered by the 2 volt battery source. Now you see this 2 volt, this is V3 and this is V4. V3 you obtained as 3 volts and V4 as 1 volts. You are asked to find how much power is delivered by 2 volts. Now if you have a battery of V volts and you have the current which is going out from the positive terminal of the battery. So here the current I is going from the positive terminal of the battery. So then the power will be delivered by the battery given by V times I. So in this case, if you see your current is entering the positive terminal, then the power delivered by the source, note the point, power delivered will be minus V times I. Having this knowledge, let us move to this question. So if you get the current, this current, say I, then the power delivered by this 2 volt source, power delivered by this 2 volt source will be 2 into I. 2 times I. Now we have to find I. You can solve from the circuit itself. You know the V4 is 1 volts. So the current, this current is 1 divided by 1 kilo ohm, which is 1 milliampere. And 5 milliampere is entering. So 5 milliampere is entering, 1 milliampere is lost. So this current is 4 milliampere. So your I is 4 milliampere. So power delivered by 2 volt source is 2 volts times 4 milliampere or 8 milliwatts is the answer. Is there any doubt in this question? Let us move on to the next question. Please go through the question. In the circuit shown below, find the values of I1, I2 respectively. Now, you have a reference node here and another reference node here. That means this potential is 0 volts. Similarly, this potential is also 0 volts. Only the potential is 0 volts. We cannot say that no currents flow through it. Since there are two grounds, we can assume a current I0 flows from this node to ground. The same current will enter through this node to top. So this is where this problem takes a turn. You cannot assume that this is 0. This may or may not exist. We don't know. So you have to include that current into consideration. Now let us discuss. So this is 0 volts. This potential is 0 volts. If this is 0 volts, then this potential is 0 plus 6, which is 6 volts. So your I1 is nothing but I1 is in this direction. So it is 0 minus 6 divided by 1 or minus 6 ampere. So you directly got your I1. I1 is minus 6 ampere. Note, make sure of this direction. Since your I1 direction is given like this, it is 0 minus 6 by 1. Now let us talk about I2. So where is I2? I2 is this current. Now you have at this node your I1 is coming and I0 is going. So this current is I1 minus I0. Just apply KCL at this node. So this is I1 minus I0. So I1 minus I0 and I2 will give you, let this be I3. If this is the case, then your I3 is I1 minus I0 plus I2. Now you already found out your I1. I1 is minus 6 minus I0 plus I2. You are asked to find I2. So I2 is I3 plus I0 plus 6. So if you are able to find I3 and I0, you can find I2. Now what is I3? I3 is this current and I0 is this current. So now I have to find both of them. Let us solve. Now I am taking this loop, outer loop, and I am applying KVL. So let this loop be A. So applying KVL in loop A. So you see there is 5 volts. So plus 5 minus 6 VA minus 2 I3 minus 10 minus 4 I3 is equal to 0. Is there any doubt in how to write the KVL equation? So this is a KVL equation of the outer loop. Now this becomes 6 VA. So there is 5 minus 10. So this is minus 6 VA minus 5 minus 6 I3 is equal to 0, or 6 VA plus 6 I3 is equal to minus 5. Now this is another equation which you got. If you know VA, you can find I3. Now, what is the relation between VA and I3? You know, I3 is the current through this branch and VA is the drop in the 4 ohms. That means 4 times I3 is equal to VA. Always make sure the polarity. So, I3 is going down. So, VA is 4I3. It is entering the positive terminal of your 4 ohms. So, if you substitute this here, you have two equations in VA and I3. You can find VA and I3. So, you substitute in this. So, 6 times VA is 4I3 plus 6I3 is equal to minus 5, or 30I3 is minus 5, or I3 is minus 1 by 6 ampere. So, you got your I3. Now, you have to get I0 so that you can find I2. Now, where we can find I0? If I got I3, I can also find my VA from here, just if it requires. So, VA is 4I3. So, 4 times minus 1 by 6 or minus 2 by 3 volts. Now, you take this 4 ohm. I1 minus I0 is a current flowing through 4 ohm. So, if you take your 4 ohm, if you redraw, the current is I1 minus I0. And this potential is 0 volts and this potential is, say, V1. Or let this be V1 and this be V2. So, this is your V2. Now, here is a controlled source, voltage source plus minus of value 6 VA, and this is your V1. Now, you see, your V1 is nothing but 5 volts because here it is 0 volts, here it is V1. So, V1 is 5. So, here your V1 is 5 volts. So, V1 minus V2 is 6 VA. So, 5 minus V2 is 6 times VA you already found, minus 2 by 3. So, your V2 becomes 5 plus this is 4. So, your V2 is 9 volts. So, if you see, this is 9 volts. So, if you write the resistor voltage current equation, 4 times I1 minus I0 is equal to 0 minus V2. So, 4 times I1 is minus 6 minus I0 is equal to minus 9. Or your I0 is minus 9 by 4 plus 9 by 4 minus 24. Did I do some mistake? So this is minus 24 minus 4 I0 is equal to minus 9. Or your I0 is minus 24 plus 9 by 4. This comes out to be minus 3.75 ampere. So now you got your I0. So in this equation, you all got I0 also. So let us solve for I2. So your I2 is I3 plus I0 plus 6. I3 plus I0 plus 6. Your I3 is minus 1 by 6. So I3 is minus 1 by 6. I0 is minus 3.75 plus 6. This comes out to be 2.083 ampere. This is the solution. So your answers are I1 is minus 6 ampere and I2 is 2.083 ampere. There is any doubt? Please ask. Let us move on to the next problem. Please go through the problem. So, in the circuit shown below, find the value of VA minus VB. So, your VA is here and your VB is here. So, in previous problems, if you are continuously attending my classes, there were times when from one circuit to another circuit only one line went and there was no return path and there was no grounds also. So we assume this current as 0 ampere. But in this case, you cannot do it because there are two reference nodes. So one path for this current I1 is possible path is this. So even though in between these two circuits, there is no direct movement of current, see if in this same problem, if your grounds was there, the point I am trying to make is if this was not given in the problem, if there were no grounds, then you can directly write your I1 as 0. But in this problem, you see, there are two grounds. So a path like this can exist. So your I1 is not 0 is my point. Your I1 is not 0. May or may not be, but it is. You cannot definitely say that it is 0. That means this exists. So you cannot remove it from the circuit. So having that knowledge in mind, let us solve for the system. So a 2 ampere flows through this path. So the 2 ampere will go through this path. So it will have a potential drop of 8 volts across 4 ohm. The same 2 ampere will cause a potential drop of 16 volts across 8 ohm. Now there is another 6 ohm. So if you draw this path, so you have a VA and you have plus minus 8 volts, you have plus minus 16 volts, and you have 6 volts, and you have a ground. Now you can apply your KVL because this VA is nothing but 8 plus 16 plus 6 because these all are additive. VA exists like this. So you apply, this is a loop. You can apply KVL. So plus VA minus 8 minus 16 minus 6 will be 0, or VA is equal to 8 plus 16 plus 6, or it is nothing but 30 volts. Right, this is 12 plus 16 is 30 volts. So your VA you got. So out of VA minus VB, this is 30 volts. Now we have to find what is VB. Now VB is in the circuit. Now let us see which one to apply, either KVL or KCL. It is up to you. You can decide whichever method you feel like comfortable. So I prefer solving from the circuit itself. So my I2 is going like this. So there will be a drop which is 8 times I2. Now the same I2 is going through this 3 ohm. So there will be 3 I2. And there is a 6 I1 here. Because this is ground, I can directly write this node potential as 6 I1. Now 3 I2 is going through this circuit. That means this is plus minus 3 I2. So everything done, right? So now you can apply KVL or KCL. So I am finding the simplest path. So I will just consider this loop similar to what we did the other side. So I have here VB here with a 2 ohm and a voltage source and ground. So this voltage source is 6 I1, right? Now I can apply KVL in this. So this exists like this, plus minus VB. And this potential is you already found as 6 I2, which you already solved here. Sorry, 3 I2 flows across 2 ohm. Nobody corrected me. This is 6 I2. So your VB minus 6 I2 minus 6 I1 is equal to 0. Or your VB is equal to 6 I1 plus 6 I2. Or 6 times I1 plus I2. Now what is I1 and I2? If we get that, we can find VB. Now what is I1 and what is I2? Where is your I2? I2 is this current. So let me So here is your I2, here is your I1. Now how can I find I1? I can choose this loop where I1 flows and apply KVL. So you have minus 5, this is plus minus 4 I1. Minus 5 minus 4 I1 plus 6 is equal to 0. Or your I1 is minus 1 by 4. No, plus 1 by 4. You take this here. So it is plus 1 by 4 ampere. So I got I1. Now what is I2? For that, I can choose a path to apply KVL. So I'm choosing this path because this path has a current source across whose voltage we don't know. So the simplest path is this path. So if you consider that path and apply KVL, so you have your 3 ohm, a potential 6I1, this is ground, this is another 8 ohm. But I'm not writing the ohm values, I'm directly writing the voltage drop. You know this current as I2. So this is plus minus 3I2, this is plus minus 8I2, and you have a voltage source 6 volts. So you just apply KVL here. So plus 6I1 minus 3I2 minus 8I2 plus 6 is equal to 0. Or 6I1 minus 11I2 plus 6 is equal to 0. Now I1 you already got, it is 1 by 4. So 6 by 4 plus 6 is equal to 11I2. Or your I2 comes out to be 30 by 4. So it is 30 by 44 or 15 by 22 ampere. So you got your I2. Now VB is nothing but 6 times I1 plus I2, which is 6 times I1 is 1 by 4 and I2 is 15 by 22. This comes out to be 123 by 22 or 5.59 volts. So your VA is 30 volts and VB is 5.59 volts. So your VA minus VB is just subtract, you will get 24.41 volts. So the answer is 24.41. Is there any doubt in this question? Please ask. Move on to the next question. In the circuit shown, given that R1 is equal to R2 is equal to 40 ohm and R3 equal to 80 ohm, calculate the voltage at node A. It's a very easy question. You can directly apply node equations at this node because you already know VB is 0 volts. So outgoing currents is equal to incoming currents. I am assuming that all currents are outgoing. So the first current, this current is, direction is from VA to 12 volts. So since 12 volts positive is here, the current is VA minus 12 by R1 40 plus all currents are outgoing. So sum of outgoing currents is 0 ampere, which is the Kirchhoff's law. So outgoing current in the first branch R1 is VA minus 12 by 40. If the 12 volt was given like this, then it is VA plus 12 by 40. Okay. Since the positive terminal comes first, VA minus 12 by 40. Why it comes like this? Because since positive terminal is like this, it has a tendency to send current in this direction. So it is opposing the direction of VA. That is why it is VA minus 12 by R1. Now the second outgoing current through R2 is VA plus or minus 6. The plus is coming here. So minus 6 by 40 plus VA minus 0 by 80 is equal to 0. So your VA is 1 by 40 plus 1 by 40 plus 1 by 80 is equal to 12 by 40 plus 6 by 40. It is a very easy question. So your VA will come out to be 36 by 5 or 7.2 volts. Very easy problem. You can also solve this using node mesh analysis, but it's very cumbersome. It is time taking process. So just apply Kirchhoff's current law at a particular node. Just make sure you know this polarity very well, whether it is plus or minus. We'll move on to the next problem. Please go through the problem. Determine the value of K that will result in Vx being equal to 0 in the circuit shown in below figure. So, you are asked to determine the value of K that will result in Vx being equal to 0. So, you can directly give your Vx as 0. So at that point, when you solve the circuit, the value of K you will get, that is the value of K that makes your Vx 0. So if Vx is 0, and this already given, this is a reference node, that means this is also 0 volts. So across R2, there will be no current flowing because both ends have the same potential. So now our circuit reduced to volts, R1, R3, this is Vy, R4, kVy, there is another 1 ampere source. So now circuit reduced to this. Now if the current flowing through this branch is I1, that is the same current flowing here also. Now I can directly apply Kirchhoff's current law at this node, similar to the previous problem. So now apply KCL at node Vy. Now this is grounded, okay. So I1 becomes Vy. Now this is minus first. So the tendency of this voltage source will be to send current in the same direction as I1. So your current equation becomes Vy plus 2 by R1 plus R3. That is the difference between the previous problem and this problem. Plus the current outgoing is 1 ampere plus Vy minus kVy divided by R4 is equal to 0. So you have Vy into 1 by R1 plus R3 Actually, since you already know this is 0 volts, we could actually simplify this because this is 0 volts. So I can make this equation simpler. Because the same current is flowing, this is Vy by R3. You don't have to write Vy plus 2 divided by R1. It is same as Vy by R3 because you already know this is 0 volts. Your Vx is 0. So this current I1 is nothing but Vy by R3 or Vy minus 0 by R3. So I can take Vy common, 1 by R3 plus 1 by R4 minus k by R4 is equal to minus 1, or Vy into R4 plus R3 into 1 minus k by R4, making the denominator common. R3 R4 is equal to minus 1, or your Vy is given by minus R3 R4 divided by R4 plus R3 into 1 minus k. Now this is your equation number 1. Now you take I1. What is I1? As I explained before, I1 is this current, which is same as this current. So you can write, so across this 2 ohm or R1, there is a voltage source minus plus 2 volt. This is grounded. This is also 0 volts. Now this current is I1, this is same I1. That means your I1 is nothing but 0 minus 2, which is plus 2 by R1, which is 2 by R1. So your I1 is 2 by R1, which is nothing but Vy by R3. Vy by R3. That means your Vy is nothing but 2R3 by R1. I just equated these two currents. They are same. So it is Vy minus 0 by R3, which is same as Vx plus 2 by R1, where Vx is 0. So I got Vy as this, 2R3 by R1. So when you compare equation 1 and 2, the LHS are same. That means RHS should be same, or minus R3 R4 by R4 plus R3 into 1 minus K is equal to 2R3 by R1. That means to take it opposite sides, minus R1, R3, R4 is equal to 2R3, R4 plus 2 or I can just cross R3 at both sides. That means 2 minus R1, R4 is equal to 2R4 plus 2R3 into 1 minus K, or your 1 minus K becomes minus R1, R4 minus 2R4 divided by 2R3, or your K becomes 1 minus R1, R4 minus 2R4 by 2R3, or 1 plus R1, R4 plus 2R4 by 2R3. Or you can simplify it much, like R4 you can take it outside, so this is R1 plus 2 by 2R3. So this is the value of K that will result in Vx equal to 0. Now you are already given the values of R1, R2, R3, R4. You can initially substitute this and solve this. I just showed you how to derive it if the values are not given. So you are already given the values. So R1 and R2 are 1 ohm, R3 is 4 ohm, R4 is 3 ohm. So if you substitute, this becomes 1 plus R4 is 3, R2 is 1 plus 2, divided by 2 times R3 is 4. So this comes out to be 2.125. So the value of K is 2.125. So if you are asked a question, find the value of something provided the other thing is 0, directly apply that to be 0 and solve. Hope it is understood. If there is any doubt, please ask. We'll move on to the next problem. Please go through the same. Okay. So if VAB is equal to 20 volts, find the current flowing through the voltage source given in the below circuit. So you are asked to find this I. You are given that VAB is 20 volts. So since there is no reference node given, I can choose this as reference. So if VAB is VA minus VB, which is VA minus 0, because I have assumed VB as reference. That means your VA is nothing but 20 volts. So this node potential is 20 volts and this is 0 volts. Let us apply nodal analysis in these two nodes V1 and V2. So nodal analysis at V1. So this current, let it be outgoing, this current is also outgoing. Now this is 0 volts. So outgoing current, sum of outgoing currents is 0. So the current flowing through R3 is V1 minus 20 by R3 plus the current flowing through 10 volt, which is I, plus V1 minus 0 by R1. These are the three outgoing currents is 0, which is your first equation. Now you have your second equation, which is the nodal equation at V2. So this is my equation number 1. Now at V2, I have this outgoing current, this outgoing current and this outgoing current. So I is anyway, the direction is fixed. So this is my I. At V2, I is incoming, which is equal to outgoing. Outgoing is V2 minus 0 by R2 plus V2 minus 20 by R4, because across R4 is V2 and 20 volts. So this is, so I can rewrite it as V2 minus 20 by R4 plus V2 by R2 minus I is equal to 0. This is my equation 2. Now you see equation 1 and 2. In equation 1, it has V1 and I as variables and equation 2 has V2 and I. But you see the coefficient of I. One is plus 1 and another is minus 1. So I can do arithmetic operations in these equations and get an expression for I, V1 and V2. Now if I do equation 1 plus equation 2, it becomes V1 minus 20 by R3 plus I plus V1 by R1 plus the second equation, which is V2 minus 20 by R4 plus V2 by R2 minus I is equal to 0. So now your I gets cancelled off. So I can write now, these values are given, it is not mentioned here. In the original question you have the values. R1 is 8 ohms, R2 is equal to R3 is equal to 4 ohms, R4 is equal to 2 ohms. So this equation becomes V1 minus 20 by R3 is 4 plus V1 by R1 is 8 plus V2 minus 20 by R4. I can replace it in the original equation. R3 is 4, R1 is 8, R2 is 4 and your R4 is 2. So when you add them, so this becomes 2 and this becomes 4. So when you add them, it becomes V1 minus 20 by 4 plus V1 by 8 plus V2 minus 20 by 2 plus V2 by 4 is equal to 0. So when you write the coefficients of V1 is 1 by 4 plus 1 by 8, and that of V2 is 1 by 2 plus 1 by 4. There is a minus 20 by 4 which is minus 5, and minus 20 by 2 which is minus 10 is equal to 0. Or your V1, this is 3 by 8 plus V2, this is 2 plus 3 by 4 minus 15 is equal to 0. So this is your equation on V1 and V2. But you have another equation which is this supernode equation. You have a 10 volt in between V1 and V2 where V1 is greater because positive sign of your 10 volts comes in the V1 side. So your V1 minus V2 is equal to 10. So this is your equation 3 and this is your equation 4. So when you consider 3 and 4, you have two unknowns. You have two unknowns which is V1 and V2, and you have two equations. So if you have two unknowns and two equations, you can solve for the unknowns which is V1 and V2, which comes out to be 20 volts and 10 volts. So now you got V1 and V2. So now the only unknown is I. So you got V2. So you already have the equation of I. I is V2 by 4 plus V2 minus 20 by 2. You have two equations on I. 1 or 2. Any one you can use. I use this one. So I is V2 by 4 plus V2 minus 20 by 2. So V2 is 10. So this is 10 by 4 plus 10 minus 20 by 2. So 10 by 4 is 2.5. 10 minus 20 is minus 10, which is minus 5. So this comes out to be minus 2.5 ampere. So that is the answer. Minus 2.5. So just application of nodal analysis. If you have any doubt, please ask. Okay, that's the end of today's class. We'll meet next Tuesday. So the next class is on Friday. It will be continuation of this, which is now we completed assignment 4. So the next class will be on assignment 5. Please try to attend all the classes. Thank you.